This video is going to cover the Algebra Unit number 2 in our MA 206 course. It is going to focus on inequalities. Inequalities we will see pop up in our probability chapters in statistics, chapters 4 and 5 and so on. So it's really good to get a handle on some of the basics and the terminologies that deal with inequalities before we get to those chapters. I'm going to be following the Word document that I posted in the Inequalities tab. On the left-hand side of our Blackboard screen, it looks like this. It says Inequalities Lesson, and that's what we're going to be following along. So it might be helpful if you print it out first and then come back to this video. Before we go into the actual sheet, though, I want to go through some very basic lessons in inequalities. So first and foremost, we have inequality symbols. This one is less than. And then we have greater than. I'm assuming that everybody knows that less than means numbers that are smaller than another number. Greater than are numbers that are more than another number. We also have two other inequality symbols. There's a less than sign with a bar underneath. That means less than or equal to. And then, of course, we have greater than or equal to. And those just mean, like, if a number is less than or equal to 5, it could be 5 or less, as compared to a number being just less than 5. That doesn't include 5. So let me just show you. If I had a number, and so a lot of times we'll just say for our number, we'll say x. If we have a number that is less than 5, and we're just talking about discrete numbers, numbers that you can count. So numbers, and let's just talk about positive ones. What numbers are less than 5? Well, the numbers that are less than 5 are 0, 1, 2, 3, and 4. Whereas when we have x is less than or equal to 5, the numbers that are included in that would be 0, 1, 2, 3, 4, and 5. So in the first one over here, 5 is not less than 5, it's not included, but over here 5 is less than or equal to 5, so it is included. And that is something that is really important for you to get a handle on, because it will affect some of the probabilities that we will be finding. Okay, so one of the things that you're going to be doing is you're going to be graphing inequalities. We don't really have to graph inequalities when we're in our probability chapters. However, it helps us to be able to visualize what numbers are included, kind of like what we just did on the previous screen. So let's look at something like this. X is less than 5 again, and let's make a number line. Okay, and we'll put arrows on the end. Alright, so a lot of times you'll see it like this. 0 will be in the middle, and then you'll have numbers to the right. You'll have numbers to the left that are negative. Okay, so to graph this, alright, well, first off, let me just show you. When you have an inequality, you're not just graphing the number 5. You're graphing all the numbers that are less than 5. All the numbers that are less than 5. So you've got to include all the numbers that are less than 5, which means we're going to do some shading. Okay, before we do that though, let me just go over a couple other basics. Okay, if you have a less than, then you are going to find the number that you're trying to graph, the inequality number, that it's either less than or greater than or whatever than. And you are going to either put an open circle on it, okay, if it's less than. If it is greater than as well, you're going to put an open circle. If it is less than or equal to or greater than or equal to, that means that it includes that number. If it includes that number, you are going to put a closed circle on it. And the reason again is, if it is less than 5, it doesn't include 5. So you put a circle on the 5, and that shows that it doesn't include the 5, but includes everything to the left of it. Whereas if it's less than or equal to 5, and you put this dot on it that is filled in, then we know 5 is included. So since we know it is not included, we're going to put a circle, an open circle, on the 5, okay? And then we are going to shade all the numbers that are less than 5. Well, what numbers are less than 5? Well, the numbers that are less than 5 are 4, 3, 2, 1, all the way to infinity. So we shade the arrow as well. Okay? Had it been greater, we would have shaded all the numbers to the right. Now, the reason we're shading and we're not just putting circles on the 4, the 3, the 2, the 1, because those are the numbers that are less than 5, right? But it means all the numbers less than 5. So not just the whole numbers, but also the numbers in between, like 4.5 and 3.1 and 2.78. All the numbers in between have to be included. That's why you shade in the entire number line to the left of 5. Okay? Okay, so let's look at another one. X is greater than or equal to -2. That means all the numbers that are bigger than -2, and it includes -2. So when it includes -2, that means we are going to do a closed circle on -2. A closed circle on -2. And let me give us a different color for our line just so we can be able to see it. Okay, now which direction are the numbers that are greater than -2? So numbers that are greater than -2 are numbers like -1, 0, 1, 2, so on and so forth. So they're the numbers to the right. So we are going to shade our line to the right of -2, and we are going to shade the arrow as well. And that's how you graph your basic inequalities. So again, if you have less than or greater than, it's an open circle. If it's less than or equal to, greater than or equal to, it's a closed circle. If it is less than or equal to, you shade to the left. If it's greater than or equal to, you will shade to the right. Okay, so let's open up that inequality lesson. And the first thing you'll see are some phrases and how they translate into inequalities. So this is probably one of the most important parts of the lesson, especially when we head into Chapter 5. You will recall this wording and why it's so important for you to understand it. You'll understand when you get there. So they start off with our basics. X is less than A, and you see X is, and then there's the less than sign. X is less than or equal to A. You've got less than with a line underneath. And then X is greater than A. X is greater than or equal to A. Greater than or equal to sign. Now, those I think that you probably will be fine with. The next four are the ones that I need you to really focus on and study. If you need to put these down on a note card for the test when we do that, that is a good idea. But the words, what does it mean when we say at most? What does it mean when we say no more than? What does it mean when we say at least? What does it mean when we say no less than? Okay, so sometimes I think it helps if we put some numbers in there so that it can help you to understand where this is coming from. So let's say if we get a problem and it says that x is at most 7. And actually, it really helps if you can add some context to this. So let's change it up even more. Let's add some context to it. Let's say x, instead of saying x, what does it mean if you say a person can be at most 7 years old to get a free kids cone? What does that mean? A person can be at most 7 years old to get a kids cone. Does it? Now, I think what confuses people is when you see most, you think more, and when we think more, we think greater than. But check out the sign here. For at most, it's a less than sign, right? So let's think about this. If a person can be at most 7 years old to get a free kids cone, the most age they can be is 7. They can't be any more than 7. So how old can they be? They can be 0, a baby. They can be 1. They can be 2. They can be 3. They can be 4. They can be 5. They can be 6. Can they be 7? Well, they can be at most 7. So yes, they can be 7. Can they be 8? No, because 7 is the most that they can be. So you can see that this is a less than problem. So if a person can be at most 7 years old to get a free ice cream cone, and I ask you to write this as an inequality, you could just say x, being the age of the person, can be less than or equal to, do an underline for the equal to part, 7. And then of course we have the graph. You can actually graph. Okay, so I'm not going to draw the whole number line, but if we had 7 years old here, then you can be 7 or less, and that would be the graph. Okay, the next one, x is no more than a. Again, they use the word more, but it's showing less than again. So let's see how this works. X is no more than a. So my mom said that I can have no more than 2 cookies. Does that mean I can have more than 2 cookies? I wish, right? No, I cannot have more than 2 cookies. So that's 2 or less. So that's why they have the less than or equal to sign. So if we were going to write this as an inequality, we would say x is less than or equal to 2. And again, it would look just like the graph up here. It's just instead of a 7, this would be a 2. The next one is at least. You see the word least, you think less, but take a look. This says greater than or equal to. So at least a is greater than or equal to. So let's see how that works. You have to be at least 48 inches to ride a roller coaster. I'm sure you've seen that when you've gone to the fair or an amusement park or something. You have to be at least a certain height to be able to ride certain rides. So I like using this as an example for myself when I'm trying to figure out, what does it mean when it says at least? And so I'll put it in my own little sentence like this. You have to be at least 48 inches to ride a roller coaster. And so if you have to be at least 48 inches, that's 48 inches or above. So that would definitely be greater than or equal to 48. Okay, I've reached the end of my time for this, so we'll do a part 2 for the inequalities.